Okay, here's Sarah here to talk about action potential. So, action potential actually begins with neural transmission, and this happens over here from the dendrites. This is my dendrite. All right, this is my soma. This is my nucleus. Okay, and the neurotransmitters from other neurons bind to sensors, causing a chemical signal. Now that triggers the ion channels to open, letting in ions, and this converts the chemical signal to an electrical signal. So now then we start to get positive things in here. Okay, and if there are enough positive ones, then that triggers an action potential down the axon here. So it goes bloop, 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 and out the other side to talk to other neurons. So there go my neurotransmitters out the other end. So these are my terminal buttons. This is my axon here. This is my nodes of Ron VA. Whoops, that's terrible writing. All right, so most of the action potential happens here along the axon. So in order to talk about that, I'm going to have to zoom in a little bit, so that triggers the action potential. So here, this is my cell, representing the outside of the cell and the inside of the cell. So I have, let me get my props. My ink cartridges here are going to represent the different gates. And then I have on the outside, I have some cranberry beans that are representing sodium ions. Oh, my cat would like to help. Hello, cat. And then I have sunflower seeds that are going to represent potassium. Daphne, go away. So the positive sodium charges, make the outside more positively charged than the inside. The inside is going to be negatively charged at around negative 70 millivolts. So what happens down here is when this gets triggered, Daphne, please move. I'm doing my homework. When this gets triggered down here, it starts opening up all of these sodium gates, and the sodium ions start coming into the cell. All right. And once it passes a threshold of about negative 50, no, Daffy, millivolts, then it's just whoosh. And I'll demonstrate that in a minute. At the same time, these potassium ions go outside, so the inside of the cell becomes more positively charged. So in the final diagram, which my lovely assistant Daphne would love to show. Daffy, move. So the way this looks, again, my lovely assistant here to help me. Looks a little like this. So the resting potential is here at minus 70. This should say minus 70 millivolts. It should say minus 50. So once that gets up to about 50 millivolts, then those sodium channels open and it's whoosh. This is called depolarization. And then once we get to about positive 40 millivolts, then those gates start to close down and the sodium ions start to come back, and we get repolarization. But what happens is it overcompensates and we get hyperpolarization before turning up and leveling out at resting potential again. So what we have here is a diagram of, yes, thank you, Daphne, for pointing that out to me, of resting potential. So here we have the hyperpolarization that goes down. Those potassium channels are going to close up. There's this refractory period here, and then it just all stables out again at minus 70 millivolts. So that's action potential.